Hi guys, in this lesson we will look at the using trigonometric functions for modeling real-time situations. And in this case we will look at the mean monthly temperature for Cape Town over a 12-month period. There's some data there, we can plot the data and we want to obtain a model from that. Now the way to do that is to use the general sine or cosine function. And here we're going to use the sine function. That's an arbitrary choice really. So the general sine function is as follows. Of course you know the sine function is sine x, y equals sine x. But in this case we will extend it a little bit. We will say y equals a and the sine of b times x take c plus d. So instead of just saying y equals sine x, that's the most easy sine function there is, we've now extended it and we've implemented an a, b, a c and a d. And these are the parameters that we can use to model the function with. So what do a, b and c and d do? Well, you'll learn exactly what they do in chapter 5 a bit later on, and it's going to be a bit tricky. But the easy bit we can do right here. A is the amplitude. And the amplitude tells us the difference between the maximum and the minimum value. So how far does it go up and how far does it go down? To find the amplitude, what you do is you find the maximum value of your data, you take away the minimum value of your data, and you divide by 2. Then I'm skipping to D here. D is the vertical translation. The vertical translation means how far does the whole graph shift up or down. So I can move the graph up or down. How do I find the vertical translation? Well, what we here find here, D, represents the principal axis of the data. So the principal axis is around here. See? That's what the data revolves around. It goes around the principal axis. How do you find it? You find your maximum data point, you add your minimum data point, and you divide by 2. So slight difference from the amplitude there. Okay, what does B do? B is the period of your data. So how contracted are these cycles? How long is one period? How long does it take to start again? And the period is 2 pi, because that's a normal sine period, over b. And b is that letter there. Or alternatively, of course, b then is 2 pi over the period of your data. Now there's one left, c. What does c do? C is the horizontal translation. So sometimes the sine function or the data does not start at 0. You see an ordinary sine function starts at 0 there. You know, it starts there. But sometimes your data, it starts maybe somewhere there and goes up like that. Not quite at 0. So we translate the data, we shift it horizontally. A horizontal shift. And to find the horizontal shift, that's the trickiest part, because we basically just have to identify where the graph starts, where it goes through the principal axis. Now let's look at this particular data using these formulae. I'm going to the next page here. Got the same problem here. And so let's see. I had y equals a sine b x take c plus d, all good. But in this case here, I don't have a y. My y is the temperature T, big T. I don't really have an x either. X is the month, and it's given here by little t, lowercase t. So I have T equals A sine B T take C plus D. Okay, let's do the easy ones first. A is the maximum, take away the minimum, over 2, which in this case the maximum value is 28, I believe, and the minimum value is perhaps 15, and we do divide by 2, and that gets us 6.5. Another easy one is D. D is the maximum plus the minimum over 2. So that's my 28 plus 15 over 2. Therefore that's 41, 40, oh wait a minute, 42 over 2. Am I getting this right? Yeah, I think so. I've got here 21.5. Of course, it's 43 over 2. Right. Great. Now another one that's not too hard is B, because B is 2 pi. You know, we're always working in radians with this modeling business, so it's 2 pi over the period of the data. Now what's the period of the data? Well, what we have here are 12 months, a 12-month period. After the 12-month period, the data sort of repeats itself, or that's what we assume at least. So it starts over again after 12 months. So the period is 12. It's going to be 2 pi over 12, which is pi over 6. So far I have T is 6.5 sine pi over 6 T plus some kind of C plus 21.5. The only thing left to find is that C here, which is a tricky bit. Now what you do is you use the principal axis. This here is the principal axis. It's at 21.5. The data revolves around 21.5, which is around here. Okay, so that's our data there. And now we identify where the sine function starts. So where it goes through the principal axis. Well, it goes through here, but it goes down. The sine function doesn't go down, it doesn't start going down, the sine function starts going up. So that's here. That's where it starts. Exactly that point there. So that point there is midway between September and November, so that's October. So January, February, March, April, May, June, July, August, September, October. October is the 10th month. Now if you graph this more carefully, then you can do a better estimation, but I'm going to go with 10 for now. The number here is 10 because 10 is October. Yeah. So C is 10, and the model is going to be T equals 6.5 sin pi over 6 T take 10 plus D. Now where did that, oh, I made a mistake. I had this negative sign all over the place already. I just made a mistake. This never needed to be a positive. It's always a negative there. So that's how you do the modeling. This is the function. We do negative c, not plus. Did I get that right before? Yeah, negative. So the value of c is 10, so it's take 10. Plus d, and I knew my d was 21.5, so write it in, 21.5. Finally, I got it. So here it is. This is the function that models the data that we have here. Yeah. So I can superimpose this function. I could draw it on top of that data there. It won't be an exact fit, but it will do the job quite nicely. And it will allow us to predict data in the future, or even predict it in the past, which is not really predicting, is it? So there you go, modeling with data. In the next video I will show you how to find this formula using your calculator, which is so much easier.